This type of infinite series is called an alternating series. So let's first see why that is. So if I'm to write out the first four terms of this infinite series, let's see. Now notice first of all that it starts at n equals 1. Now why is that? Why doesn't it start at n equals 0, right? This is because if we put n equals 0 into that, we'd be dividing by 0. So sometimes our infinite series start at n equals 1, sometimes they start at n equals 2. In any case, this one's starting at n equals 1. We have negative 1 to the 1 over 1 to the 4th plus 1. That's the n equals 1 term. Then negative 1 squared over 2 to the 4th plus 2. That's the n equals 2 term. Plus negative 1 cubed over 3 to the 4th plus 3. Negative 1 to the 4th over 4 to the 4th plus 4. Continuing on forever. Right, this is the n equals 3 term and the n equals 4 term. Now simplifying, here we get negative 1 over 2 plus 1 over 18 plus negative 1 over 84 plus 1 over 260. And notice that we could write this as negative 1/2 plus 1/18 minus 1/84 plus 1 over 260. And then the next term, right, this being the n equals 4 term, the next term will be the n equals 5 term. Negative 1 to the 5th power, that'll be a negative. So the next one will be negative, continuing on like that. And so this is where the alternating part comes in, right? So it's alternating because in this case it starts negative and then turns positive, and then goes negative, then goes positive. A lot of them, if they start at n equals 0, will start positive and then be negative. But in any case, you can see that the signs alternate. So this is why we call it an alternating series. And now we want to determine if this alternating series converges or diverges. So let me first just write it up here, 1/2, and I'm writing it up here to get at a specific point that's going to help you with your homework. All right, so here we have this thing as an alternating series. And we have a theorem that says that if the positive term series, or the series that replaces all the negatives with positives, converges, then the original series converges. And so what I mean by that, so these are different series, so I don't want you to think that these are equal. Let me get rid of this equal sign here. So if we make these all positive, right, this is going to be positive 1/2 plus 1/18 plus 1 over 84 plus 1 over 260 plus. So you can see these are not the same series, right? These are definitely not equal. But we have a theorem that says that, so I'll put this line in between to indicate that these are not the same thing, right? That if this series here converges, then we know that this series converges. And so that'll be your goal with a lot of these problems in the homework that are alternating series, is you just look at the thing where it's positive, Most often, the thing that makes it negative, makes it alternating, is that you have this negative 1 to the n. And so then to make it positive with the rule, all you do is make the negative 1 to the n into an n, or into a 1, right? So, sorry, I misspoke there. You just make the negative 1 to the n into a 1 to make it into all positive terms. All right, so now we need to decide whether or not this series converges. And if it converges, then we know that the original series converges. That one. All right, so this one here, let's see. So notice that this one here looks very similar to 1 over n to the fourth, right? Or looks very similar to the infinite series 1 over n to the fourth, which is a convergent p series. P is equal to 4, which is greater than 1. So this thing is convergent. So let's think, can we compare those two series? All right, so n to the fourth is less than n to the fourth plus more. So that tells us that 1 over n to the fourth plus n is less than 1 over n to the fourth, which tells us that now again, this is convergent, right? This is a convergent p series. P equals 4 greater than 1, so it converges. Remember, smaller than convergent is convergent, so that tells us that this converges. This converges. And so since this thing here converges, we know that its associated alternating series, this thing, converges. So the answer is converges.